In today's video, I would like to introduce a very nice problem. Here is the following equation. Our goal, we are going to solve this equation in real numbers, okay? This equation is involving the trigonometry function inside of fifth root, okay? So let's check this one to see how to solve this one. You take a look at these two parts of this equation. So let's go through this one. I get here fifth root of sine x minus number 1 minus fifth root of sine x minus number 1 minus number 1. I have split this one into two parts, as I said before, equals number 1. So I'm simply going through substitution here by putting this one as a z. So I get here sine of x minus number 1 equals z. So my equation is going to be in terms of z. So I get here z to 1/5. So this minus z minus number 1 to the 1/5, okay, equals number 1. The equation is already reduced to the smallest expression. I'm simply going to move over this term to the right and bring number 1 to the left, okay? So I get here z to the 1/5 minus number 1 equals z minus number 1 to the 1/5, okay? So in order to make this equation simply to solve, I'm simply going to get rid of the exponents, 1/5. So I'm going to raise both sides to the 5th power. If I'm going, this exponent is going to cancel down to the number 1 here. Then also I'm going to put another substitution. Let's set z to the 1/5 equals t, okay? So the equation is going to be more simplified. I get t minus number 1 to the 5th power equals z minus number 1. Also z is going to be replaced with t to the 5th, like this, okay, minus number 1. So I'm simply going to distribute this term. We have the power of 5 here. So I get here t minus number 1 to the 5th equals, simply going to expand this one out by putting this one on this form, t minus number 1 quantity square t minus number 1, like this, okay? I'm going to expand this one, which is inside, becomes t square minus 2 times t plus number 1 and quantity square. The other one becomes t minus number 1, like this. This one equals to t to the 5th minus number 1, okay? Expand this one out, I get t square minus 2 times t quantity square plus 2 times is multiplied by 1 and is multiplied by this one. So I get plus 2 is multiplied by t square minus 2 times t plus the last term, which is number 1. So this one, it was multiplied by t minus number 1. Entire thing equals t to the 5th minus number 1. What I did here, just consider this one as a one term, then apply the quantity square formula, okay, which give us this one, okay? Now I'm going to distribute this one more. I get t to the 4th. I get minus 4 times t cubed by distribute this one also, plus the last term, which is 4t squared. This one is giving us 2 times t squared minus 4t, okay, plus number 1, okay? This one is multiplied by t minus number 1 equals, I'm going to simplify this one. I get 6t squared, okay? Then work out with this one. I get to simplify this one more. I get here t to the 4th minus 4t cubed plus 6t squared minus 4t plus number 1. The whole thing, it was multiplied by t minus number 1. So the entire thing equals t to the 5th minus number 1, like this, okay? I'm going to use the trick without expand this one out, because once you expand this one out, sometimes you will hard to factor out again. Okay, so since we have t minus number 1 is multiplied by this one, also I'm going to extract t minus number 1 out of here. Okay, so by putting this one on the form of t minus number 1 factor t to the 4th plus t to the 3 plus t squared plus t plus number 1, like this. Okay, then I'm going to take two cases. Case number 1, if t minus number 1 different than 0, I'm going to divide both sides by t minus number 1. I get t minus number 1 cancelled out. I will be left with this. I will be left with this expression equals to this expression. If this one equals to this one, I'm going to cancel out some stuff here. I will cancel t to the 4th with t to the 4th. Okay, here is a nice thing when I cancelled out this one with this one. Okay, I get minus 4t2 cubed at the left hand side of this equation. I get t cubed at the right hand side of this equation. Okay, so this t minus number 1 is already cancelled out if t minus number 1 is different than 0. If t minus number 1 equals 0 is a problem. Okay, I'm going to move over this one to this one, put them together. I get minus 5t cubed. Okay, moving on to the 6t squared here, with this t becomes just 5t squared. I have minus 4t here, I get t here. Moving over this t, I get minus 5t. Then plus number 1, with this plus number 1 it will be cancelled out. Okay, so I will be left only with 0 here, 0. Okay, another nice thing here, I'm going to take minus 5t as a common factor. Minus 5t, I get here t squared, I get here minus t plus 1 equals 0. Okay, I'm going to prove this one strictly superior than 0. So this one is giving us t minus half quaternary square. Okay, give us t squared here minus t plus quarter plus 3 over 4. This one is strictly superior than 0, which means t must be equal 0. If t equals 0, I'm going to solve this equation simply, because you already put t equals 0. T equals 0 here, which means z equals 0. If z equals 0, which means everything equals 0 here, sine x minus number 1 equals 0, equivalent sine x equals number 1. Sine x equals 1, it's clearly x equals pi over 2 plus 2 k pi. Okay, be careful here. If you put k pi here, here is a problem. This is pi over 2, this is 3 pi over 2, 0 pi. Okay, so by putting this one on the unit circle, I get here. I'm going to turn around with 2 pi in order to get to the same points. You cannot be here. If you get be here, you get minus number 1 is negative. Okay, because if it's there, we put only k pi, which is impossible. We must put 2 k pi here. So this is the solution. Be careful here, it's so confusing. If you have a k as an integer number, which is k is negative, if for example if you are taking k equals minus number 1, we get here minus 2 pi. Minus 2 pi plus pi over 2 is giving us minus 3 pi over 2. Minus 3 pi over 2 is here, which is minus number, which is the value of the sign of this point equals minus number 1. Is not going to be a solution. Okay, if you replace a sine x with a negative value, because this minus number 1 is going to be inside, becomes with this minus number 1, with this minus sign, we'll get plus. Plus, we get this, with this plus, you have a positive number which is bigger than number 1. You're never gonna get number 1 here. But you get number 1 here, the only if you have only the value of sine x equals 1, not minus number 1. In order to avoid that problem, I'm going to put k must be a natural number, not integer. Okay, so you have to plug k with a positive number only here. So pi over 2 plus this point here, put minus sign here, it gets you to this point. Okay, I get only one solution when we have t minus number 1 equals 0, but we still have another case. What about if t minus number 1 equals 0? Okay, if t minus number 1 equals 0, if you remember, we have divided by t minus number 1 if we have t minus number 1 must be different than 0, then we allow to divide by both sides by t minus number 1. Otherwise we cannot divide by t minus number 1. If t minus number 1 equals 0, you will have 0 in the denominator, which is impossible. So now we have to take that case. If t minus number 1 equals 0, this one is telling us t equals number 1. If t equals number 1, by going back to the substitution, I get z to the 1 over 5th equals t equals number 1. This one is telling us z equals number 1. Raising to the power 5th on both sides, I get to the 5th. I get 1 to the 5th, which is number 1. Z equals 1, which means sine of x minus number 1 equals 1. Okay, I get here sine of x minus number 1 equals 1. By taking minus number 1 to the right, I get sine of x equals number 2. Sine x equals number 2 is strictly ridiculous, okay, which is a big contradiction here, okay, which is impossible. Sine x is always inferior to number 1, okay. So we have no solutions when we have t minus number 1. So the only solution that we have this one, x equals pi over 2 plus 2k pi for some k as a natural number. So you have ended this video. If you have any question regarding this problem, just put it in the comment section below. If you have any question or suggestion, put it in the comment section below as well. By the way, don't forget to hit the subscribe button. And thank you for watching. Enjoy the rest of your day. Bye.